So happy Friday, here we go again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during this meeting, but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Okay, so today we're reviewing for a test on Monday. And so Monday, there will be no Zoom meeting at 10:30. You just take your test Monday. Once you open it, the time starts. You have, what is it, I think 75 minutes. And it's due no later than Monday night at 11:59. Okay. Anyway, I've got a bunch of questions that people have emailed me, requested. So I'm going to start with those, and then I'll open it up to whatever else if people have questions. This actually goes back to section 5.8, part 1. And this is number 9. And it says divide the polynomial by the monomial. And it has b squared plus b cubed minus b to the fourth all over b to the fourth. I'm pretty sure we did one just like this the other day, but that's okay. We'll do it again. So when you have a polynomial divided by a monomial, you're going to take each term in the numerator and divide it by the denominator, creating separate fractions, and then you're going to go through and reduce each fraction. Now, keep in mind, even though the directions don't say this, there is an assumption built in with exponents. Unless it says otherwise, or unless you're doing something in scientific notation, which we haven't touched on at all and won't be, unless it's one of those two things, you always want your final answer to have exponents that are positive, okay? Recall, if you have a base to a negative power in the numerator and you move it down to the other side of the fraction bar down below, it changes the sign of the exponent to a positive exponent. All right, so let's take this first term, b to the second divided by b to the fourth, dividing two powers with the same base. You take the base with the top exponent minus the bottom exponent, which becomes b to the -2 power, which we could rewrite as 1 over b squared. So this term becomes that. All right, let's take a look at this second term. Very similar situation, b cubed over b to the fourth, b to the 3 minus 4, b to the -1, 1 over b. So this term becomes that term. And finally, the last term, b to the fourth over itself would be 1, or you could make it b to the 0 power, which is also 1. So it's going to be -1. So your final answer is 1 over b squared plus 1 over b minus 1. Any questions on that before we go on? Okay, we've got one more to look at back in 5.8 part 1. This is number 11. It says divide the polynomial by the monomial. We have a similar situation. We've got -35 x squared y cubed plus 42 xy squared minus 7xy all over -7x squared y squared. So we're going to take each term in the numerator and divide it by the term in the denominator. So we're going to get -35x squared y cubed over -7x squared y squared plus 42xy squared over -7x squared y squared minus 7xy over -7x squared y squared. All right, let's focus on that first term. The coefficients, -35 divided by -7 reduces to 5/1. X squared divided by x squared is 1. So 1/1. Y cubed over y squared is y to the 1 power. So I've got 5y. 5 times 1 times y to the 1 power all over 1 can be simplified down to just 5y. Okay. Next term, 42 over -7 reduces down to -6 on top. X over x squared becomes x to the -1 on top. Y squared over y squared becomes 1. So I've got plus -6x to the -1. Okay, but that could be written as -6 over x, because x to the -1, we put it downstairs and make it x to the +1. And then I don't need to actually write that implied 1 exponent. Okay, so I've got 5y minus 6 over x. Third term, 7 over -7 reduces to -1/1. X over x squared becomes x to the -1 on top. Y over y squared becomes y to the -1 on top. I've got subtracting a negative, so that's going to be like adding a positive, so plus 1. But then I've got x to the -1, move downstairs, is x to the +1. Y to the -1 upstairs, move downstairs, is y to the +1. So there's your answer. Okay. Any questions before we go on?
I have one.
Yes.
So, do we only separate each one, like the -35x to the second y cubed over -7x to the second y to the second? Do we only separate each one of those when we're dividing a polynomial by a monomial? I think that's what okay, yep. That's what I think I'm messing up on.
That's the deal. Only then and always then.
Okay.
Okay. So now let's see, we're going to go back and now we're going to look at some questions from 5.8 part 2. And let's see, that's review. That's okay. Let's see, number 9. Okay. So this is 5.8 part 2, number 9. Perform the division. We have -56 f to the 4th power plus 28 over 7 f to the 3rd power. So once again, we have a polynomial divided by a monomial. So we're going to take each term in the numerator and divide it by the denominator. Okay. Dealing with it a term at a time. The first term, -56 divided by 7 becomes -8 over 1. F to the 4th over f to the 3rd would be f to the 1 power. So -8 f to the 1 power all over 1 just becomes -8 times f. Next term, 28 over 7 is 4 over 1. F to the 3rd power in the denominator has a positive exponent, so we don't need to do anything to it. So there's the final answer. And again, you could also write it 4 over f cubed minus f to the 8th, excuse me, minus 8 times f. Okay. Number, what do we got here? Number 10. This is still in 5.8 part 2. Number 10 says, perform the division. A cubed plus a over a plus 3. So we have a polynomial divided by a polynomial. So we're going to use the long division form. Outside, I'm going to have a plus 3, but inside, I've got some missing terms. So I'm going to write a cubed plus 0a squared plus 0a, oh, not plus 0a, my bad, sorry. Come on here. Yeah, plus a. There we go. Now, do I need, and I'll put plus 0 for the constant term. Okay. We may or may not need that last 0. We'll find out when we get there. All right, so leading term inside divided by leading term outside. A cubed divided by a equals a squared. Write that up there in the appropriate column. Take a squared times a plus 3, a cubed plus 3a squared, a cubed plus 3a squared. Draw a line, subtract that quantity from what's up above, change it to addition of the opposite. A cubed plus negative a cubed is 0. 0a squared plus negative 3a squared is negative 3a squared. Okay, bring down the next term and start the whole process over again. Divide the leading term inside by the leading term outside. Negative 3a squared divided by a is negative 3a. Okay. Take negative 3a times a plus 3. We get negative 3a squared minus 9a, which we write up here, negative 3a squared minus 9a. Again, if I'm going too fast, let me know, I can slow down. I'm going to subtract that quantity from what's up above, change it to addition of the opposite, and add up the columns. Negative 3a squared plus 3a squared is 0a squared. A plus 9a is 10a, and then plus 0. Okay. Leading term inside divided by leading term outside. So I've got, let's see, 10a divided by a is 10, so plus 10. I'm going to take 10 times a plus 3, which is 10a plus 30, so 10a plus 30. Subtract that quantity from what's up above. Change it to addition of the opposite. 10a plus negative 10a is 0. 0 plus negative 30 is negative 30. So my quotient is a squared minus 3a plus 10. My remainder is negative 30. But the way I'm going to write that whole answer is going to be a squared minus 3a plus 10. And then minus what? 30 over a plus 3. Earlier on, when I introduced this idea, I said that the author of the textbook always wrote plus the remainder, so they put a plus sign and then the negative sign above the 30. However, in WebAssign, I'm seeing that they wrote minus the 30 over a plus 3. So I guess, you could try both ways and see, but this is the way they're doing it in WebAssign. So whoever did the key to the textbook wasn't the same person that did the key to WebAssign, unfortunately. Both ways should work. All right, I've got one more here. And this is number 15, part A. Again, we're still in section 5.8, part 2. It says perform the indicated operations, or operation in this case. Let's see, part A. We have 27 x cubed plus 6x squared plus 14x plus 5 divided by 3x. So we've gone back to a polynomial divided by a monomial. So we take each term in the numerator and divide it by the denominator. And then we go back and we simplify each term, term by term. 27 over 3 is 9 over 1. X cubed over x would be x squared, so we get 9x squared. 6 over 3 is 2 over 1. X squared over x is x, so 9x squared plus 2x. 14 over 3 doesn't reduce. X over x reduces down to just 1, so plus 14 thirds. And finally, the last term doesn't change at all. So there's our, that's supposed to be a 9x squared. There's our last answer there. Okay, that takes care of those questions. Now we're going to look at the chapter review. Let's see here. I have 4775 and there. Okay, chapter review. Number 18. Okay, so this is chapter 5 review, number 18. It says, find the product. Before we do this problem, I want to look at a different problem for a minute. Suppose you had -6 squared as opposed to -6 squared. Okay, the one on the right, the base is -6. So this would be -6 times -6, which is a positive 36. The one on the left, the base is just the 6. So that's 6 times 6, which is 36. And then you'd bring down the subtraction or the negative sign. Okay, we need to understand that. Now let's go back here and take a look at this problem. It says find the product. We have a negative sign outside of the parentheses. So order of operations, we're going to do the exponent first. Okay, now I have two choices. I could distribute the negative sign that's outside to the first set of parentheses and change it to -6a plus 5c and take that quantity and distribute it. Or I can do the two factors in parentheses first, get that product simplified, and then distribute the negative sign. I'm going to do it the second method. So basically, I'm going to do this first. Okay, so I'm going to get 36a squared. And either method works. This is just my preference. And if you want, I'll go back and do it the other way in a minute. You tell me and I will. Then I've got what? Minus 30ac minus 30ac plus 25c squared. And all of that still has that negative sign in front. But this is 36a squared minus 60ac plus 25c squared. Again, now we're going to apply the negative sign. So we're going to get negative 36a squared plus 60ac minus 25c squared. And there's the final answer. Does anybody want me to go back and do it, distributing that negative sign through the first set of parentheses?
Yes.
Okay. Be careful. You don't want to distribute it through that whole thing. Okay. So now here we go. If we've got this, let's see, what is it? Minus 5c. Okay. So the first thing we would do is expand it. Then I'm going to distribute it through the first set. So I'm going to get negative 6a plus 5c. Okay. Now I'm going to take that resulting parentheses and distribute that. So I'm going to get negative 36a squared plus 30ac plus 30ac minus 25c squared. Combining like terms, I get that, which is the same thing I got there. Okay, but you got to be careful. What you don't want to do is this. You've got to expand that and then just distribute it to the first factor. Okay, if you're going to go that route. So be very careful with that. All right, we good to go on that one?
Mr. Mayo?
Yeah.
Yes.
Wouldn't the first 30 AC be? Oh wait, never mind. Never mind.
Okay. Take a look. Make sure. I've never made any mistakes. Well, at least not in the last 5 minutes. But who's counting, right? And the sad thing
No,
is,
never mind. Never mind.
You see it?
Yeah, I see it.
And all my
Negatives always confuse me.
Okay, all my mistakes are out there on YouTube for the world to see. It's a proud moment. Okay, I got over myself long ago. Okay, let's see here. We're gonna look at number 19. And that says divide. Here it says, do not use negative exponents in the answer. Okay, and that's they were kind in saying that because it should be assumed whether they say it or not. But anyway, so negative 14 x squared y over 21 xy cubed. We've got a monomial over a monomial, so we've just got a single fraction that we're going to simplify if we can. Negative 14 over 21 would be negative 2/3. X squared over x would be x to the 1 power up on top. Y over y cubed would be y to the 1 minus 3 or y to the negative 2. So I've got negative 2x y to the negative 2 over 3. But then that's going to be negative 2x over 3, moving that downstairs, y squared. Okay. Now, you can write it this way with applying that negative sign to the numerator, or you could write it as a negative out in front of the whole thing. Since there's only one term in the numerator, yeah, you can do it that way. There we go. All right. That takes care of that, students. Let's go back here and let's see here. We need 4770 and there. And chapter review. Number 4, 7, number 9.
Can we try doing problem number 20 on chapter review?
Yeah. Let me just do these really quick, and then we still got time. We'll take questions from our studio audience. But I'm confused because I'm looking at the questions the student asked for, and they're all correct. So I don't know. I don't know if they finally figured them out. It's not going to take that long to do them. I'm just going to go ahead and do them anyway, and then we will get to your questions. Absolutely. Okay, so what I'm going to do first of all is I'm going to share the picture. We're taking a look at problem number 4, and you see the shovel there, okay? It says, find a polynomial that represents the length of the wooden handle of the shovel. All right, f of x is the entire shovel, okay? So the entire shovel is 3x squared plus x plus 1. The part of it that's just the metal, I don't know what you call that, the spade or the head part, is x squared minus 4. If we want just the handle, we're going to take the whole thing minus the metal part. So we're going to take 3x squared plus x plus 1 minus the quantity x squared minus 4. Does that make sense? Hopefully?
Yeah.
Okay. So basically, we're going to do this problem, which becomes 3x squared plus x plus 1 minus x squared plus 4. Combining like terms, 2x squared plus x plus 5. And that would be inches. Okay. Any questions there? All right. Now we're going to look at number 7, which says multiply, simplify your answer completely. We have 4/5 h to the 8th power times 5 h to the 15th power plus 20 h to the 10th power. We're going to distribute. Since there's fractions involved, I'm not going to do it simplifying as I go. I'm first of all going to say, okay, we're going to have 4/5 h to the 8th times 5h to the 15th, and then plus 4/5 h to the 8th times 20 h to the 10th. And then I'll come back and simplify, okay? So this 5h to the 15th is over 1, so those 5s would reduce down, and I'd have 4h to the 8 plus 15 is 23rd power, okay? Plus, here, 20 over 5 would be 4 times 4 is 16, h to the 18th power. So that's our final answer there. Okay?
Hold on, let me write this down.
Absolutely.
I haven't come across a fraction like this yet.
Okay.
All right, thanks.
You're welcome. Okay, so here is number 9. It says multiply, simplify your answer completely. We have negative a to the 4th b to the 4th times negative a to the 6th b to the 4th plus a to the 5th b to the 5th minus ab to the 6th plus 9a. Don't confuse a negative exponent with a negative coefficient. This particular problem has no negative exponents. There's some negative coefficients, but that's different. So don't get those two confused. All right. So negative times negative would be positive a to the 10th, b to the 8th. Negative times positive is negative a to the 9th, b to the 9th. Negative times negative is positive a to the 5th. Don't forget there's an implied 1 on that single a, okay? And then b to the 10th. And finally, negative 9a to the 5th, b to the 4th. Okay, so now one of you had a question. I believe it was problem 20 on the chapter review. Do you want me to do your specific one or just whichever? What do you want to do?
I would rather prefer the specific one I have.
Okay, you want to tell me what it is?
Yes, it's 15a to the power of 5b plus ab to the power of 2 minus 9b. And then that's over 3a squared b.
Okay. So we have a polynomial divided by a monomial. We're going to take each term in the numerator and divide it by the term of the denominator. So we're going to have 15a to the 5th b over 3a squared b plus ab squared over 3a squared b minus 9b over 3a squared b. So term by term, the first term we're going to reduce. 15 over 3 is 5 over 1. A to the 5th over a squared is a to the 3rd. And b over b is just 1 over 1. So I've got 5a cubed times 1, which is still 5a cubed, all over 1, which is still just 5a cubed. So far, so good?
Yes.
Okay. Next term. a over a squared would be a to the negative 1 on top. B squared over b is b on top. So I've got plus a to the negative 1b over 3. However, I want to move that a to the negative 1, move it downstairs and make it a to the positive 1 power, and I don't need to put the 1 exponent because it's assumed. All right.
Why is that?
Why is what?
Why did you move the A or the in A, that one, down?
Okay, because it had a negative exponent and we want to write it with positive exponents, so we had to move it downstairs to change the sign of the exponent.
Okay, thank you.
Uh-huh. All right. And finally, 9 over 3 is 3 over 1. A squared is positive in the denominator, so leave it alone. It's fine. B over B is just 1. So I've got what? Minus 3 over a squared. So there's my final answer. Okay with that one?
Yes, thank you.
Mhm.
These are the ones I have a lot of trouble with. What is some ways that you recommend is easiest to solve these?
Basically what I'm doing here, and that is focus on one fraction at a time. And if you need to, you can even break it down further. For instance, let's do this. Let's see. Let me deal with just that piece. So I've got ab squared over 3a squared b. I could even separate it into that piece, and that piece. Okay. The 3 isn't going anywhere. So now let's look at a over a squared, this piece right here. Okay. That would be a to the 1 top exponent minus bottom exponent, which is what's 1 minus 2? That's negative 1. But that would be equal to 1 over a. So how would that translate up here? That would translate like that. And then the b squared over b, that's b to the 2 minus 1, which is b to the 1 or just b, but that's up on top. And I don't need that 1 any longer, so I could just write b over 3a. Is that making any sense?
Yeah, okay, so the first two monomials made sense, but the last one is what I had trouble with. Okay, so I did it right, but I didn't put a squared under -3, and that's where I got confused. I just left it as a whole number.
So this one here. Okay,
Yes.
so let's take a look at that, which was negative 9b over 3a squared b. 3a squared b. That's the one? Yeah.
Yeah.
Okay. All right. So focusing on just the numbers, negative 9 over 3 would be negative 3 over 1. Okay.
Oh, okay. I see where you did that. That makes a lot more sense now.
Okay. This, whoops, is a squared on the bottom. It's not going anywhere. B over b reduces down to b to the 0 or just 1. So you got negative 3 over a squared. Anyway, you're okay with that, you said?
Yes, that's
Right.
fine. I feel like another easier way would to write out the exponents. So if there's 5, I would write out 5 a's and just cross them out. Would
Okay.
that be a method to use as well?
That would be a method to use, but what if you had this problem? Would you want to write out 23 a's?
No, but
Just say.
you would just subtract it, no? 23 minus 2.
Right. Okay, so that would be a to the 21. What if you had this? What would you do with that?
I believe it'd be a over negative 21. A to actually no, I don't really know how to do that one either.
That would be a to the 2 minus 23, which is a to the minus 21, which would then be 1 over a to the 21 power.
Oh, okay, I see what you
Yeah.
did there. So that one has to be there in order to
Yeah.
for that equation to be right.
Yes. Yes.
Okay, I see what you did.
Yeah. And the method you suggested is not wrong, but if the exponents got large, you wouldn't want to do it that way. So that's why I'm saying you want to know the rule,
Yeah.
the shortcuts, not just the long ones kind of thing. Okay.
Yeah, that's how my other math teacher taught me, but I think both methods methods work the same.
They taught you to write them all out.
Yeah, because
Yeah.
we used to do smaller
Yeah,
equations with
exactly.
less than
Sure.
at least 10 components. Yeah.
And with small ones, that's fine, but neither one of us want to write out 23 consecutive A's for sure. Yeah. Okay. What else? Anybody, any questions? Bring them on. We'll look at them.
I have a question. Will we be dealing with graphing in this review at all?
No, in this test, no, there was no graphing problems in this chapter. At least I don't think so. No, there wasn't. So nope, won't be any graphing problems on this test.
Oh,
But
okay.
there's more
thank you.
coming later.
Oh no.
Oh no.
Mayo,
What, P?
can you do, which one? It's in 8.2.
Oh, wait, I'm sorry. It says Able P. I should have said, what, Richard? That's Mr. Mayo to you, ma'am. Okay, Carly, what was it? What do you want?
It's number 5 on 8.2. I'll tell you what it is.
8.2?
5.8, 5.8 part 2. I'm confused. The
Okay,
second part.
but you're going to tell me what it is, so it doesn't
Yeah.
matter. Sure.
Okay, so it's 3x minus 1. And then the dividend is 11x minus 4 plus 12x cubed minus x to the second.
So have I got that written out correctly?
Yes.
So basically, and good for you for calling the dividend correctly. The divisor's outside, the dividend's inside. So the dividend is not in descending powers. So we're going to fix it. So we're going to rewrite this as 3x minus 1. And inside, we're going to have 12x cubed minus x squared plus 11x minus 4. And note that there's no missing powers. So that's good. All right?
Yeah.
So here we go. Leading term divided by leading term. 12x cubed divided by 3x is 4x squared. Get rid of this. Okay?
Okay.
4x squared times 3x minus 1 is 12x cubed minus 4x squared. 12x cubed minus 4x squared. Okay?
Okay.
We're going to subtract that from what's up above. Distributing the subtraction sign, changing it to addition of the opposite. 12x cubed minus 12x cubed or plus a negative 12x cubed is no x cubed at all. Negative x squared plus positive 4x squared would be 3x squared, and then bring down the next term, the 11x. All right. Starting over, 3x squared divided by 3x is x, so plus x. X times 3x minus 1 is 3x squared minus x. We're going to subtract that from what's up above, change it to addition of the opposite. 3x squared plus negative 3x squared is 0x squared. 11x plus x is 12x. Bring down the next term, minus 4.
Okay.
Leading term divided by leading term. 12x divided by 3x is 4, so plus 4. 4 times 3x minus 1 is 12x minus 4, so 12x minus 4. We're going to subtract that from what's up above. we're going to change it to addition of the opposite, and we get 0 remainder. So the final answer, there's the quotient, and there is no remainder.
Okay.
That and 50 cents will get you 2 quarters.
Okay, that makes sense. I'm just bad at long division, is all.
Yeah, and each individual piece isn't so difficult, but it's like there's all that stuff in one problem. So I know
Yeah.
People struggle with this sometimes. What else? Any other questions?
What did you mean by what was it? Missing terms in the long division?
Okay, so let's see. Did we let's say we got like x squared minus 9 divided by x plus 3. So when you write it out, you put in a 0x. You put in a missing term to create a column. That was like the stuff we looked at yesterday. That's what I meant by a missing term.
Okay. I think that's another thing I messed up on too, probably. That makes sense. I get it. I understand it. I just don't think I did it.
Yeah, sure.
Okay.
So it's just
it's a placeholder.
Yeah, if there's a variable with a higher power, you just put a lower power with
Let me give you an
that's
example.
multiplied by 0.
Let me give you an extreme example. And I'm not going to finish the problem. I'm just going to set it up. Let's say I had 3x to the 5th minus 2x cubed plus 7x squared minus 3 all over x plus 2. Okay. This is how I would write that out in long division form. X plus 2 on the outside. On the inside, I'd have 3x to the 5th plus 0x to the 4th minus 2x cubed plus 7x squared plus 0x minus 3. Now, why did I put those in? Because I was missing 4th degree and 1st degree.
Okay, thank you. That solved my question perfectly.
Well, it's nice to have something perfectly for a change. What else? I'll tell you what, I will still be back at 1:15 today for an office hour. So if you come up with anything else that you just have to know, okay? And then again, Monday, if you show up at 10:30 here for a Zoom meeting, you will see a sign that says, take your test, or no Zoom meeting today, take your test, okay? And then I will see you again on Tuesday when we'll go on to the next chapter. Have a good, safe weekend, and we'll see you later.
Thank you.
You're welcome.